So here we are going to consider it is an infinite long straight wire carrying current. By using Biot Savert law, we are going to measure the magnetic induction at the point P. We know the formula according to Biot Savert law. dB vector is equal to mu naught by 4 pi I dl sin theta divided by r square. Okay, so here theta is the angle between the point where I am measuring the magnetic induction and with the current element. So in order to take the current element, I have taken the small current element, that is AB. Okay, so from the, let me take, this will be the midpoint O. From the point to here, I have taken the distance A. From the point A to P, I have taken the distance R. And this will be making an angle phi. Now this is a current element, okay, having the small length dl. Okay, from here to there I just make another one point, that is BP. Okay, now I have point C. Okay, now so this will be making an angle theta. This will be making an angle theta, that is the current element making an angle theta with the point where I am measuring the magnetic induction. First, let us solve this triangle, that is triangle ABC. In the triangle ABC, okay, I am just writing what is sine theta. Okay, sine theta will be equal to, see, this is theta and this is right angle. So this will be adjacent side and this will be opposite side. So the sine theta will be equal to, okay, AC by AB. AC by AB. Or AC is equal to AB sin theta, that is DL sin theta. Okay, so in the formula DL sin theta, I can simply write, instead of DL sin theta, I can simply write AC. But what is AC? I have to write in terms of some other value. For that, I am going to consider the triangle APB and the triangle APC. Triangle APC. Of course, both are same. The triangle APB and APC will be same, and especially its angle, let me take, this is d phi. When I am comparing the angle phi, the angle d phi will be very small, so I can just take it d phi. Okay, when the angle will be small, sin theta can be taken as theta. I am going to use that principle. Okay, so here I can measure what would be sin d phi. That is sin d phi will be equal to, in the triangle APC. Okay, let me take adjacent side. This is opposite side. So AC by AP. AC by AP. That means AC is equal to AP sin d phi, or okay, AC is equal to R sin d phi. That means R d phi. Why? Because when theta is very small, I can simply take, okay, sin d phi will be equal to d phi. So finally I will get R d phi. AC will be equal to DL sin theta, or AC is equal to R d phi. So what is its meaning? Instead of DL sin theta, I can simply write R d phi. This is what I am going to do. So now this equation will become dB will be equal to, okay, mu naught by 4 pi into I. Instead of DL sin theta, I can simply write AC. AC will be equal to R into d phi. So R d phi divided by R square. So I can cancel 1 R, 1 R. Okay, what will happen to the final value? I will get the final value will be equal to, that is mu naught by 4 pi into I into d phi by R. Now I have to remove this R in terms of A. For that, I am just taking the triangle OPA. The triangle OPA. See, this is angle and this is adjacent side, and this is on, this will be opposite side. Okay. So now I am just taking what will be the cos phi. Cos phi will be equal to, okay, adjacent side divided by hypotenuse. Okay, that means cos phi will be equal to A divided by R, or R will be equal to A divided by cos phi. Now I am going to substitute the value of R is equal to A divided by cos phi in this formula. Okay, I will get B will be, or dB will be equal to mu naught by 4 pi into I into d phi. Instead of R, I can substitute A. Cos phi will go up. Cos phi. Okay. So this is what the final value I am getting. Okay. Right. So now I have got dB vector, or dB will be equal to mu naught by 4 pi into I by A. Okay. Into cos phi d phi. Cos phi d phi. See, this is a small value due to the small current element. But what is my aim? To measure the total magnetic induction throughout the long straight wire. For that, I have to integrate it. See, in order to measure the total magnetic induction due to this wire, I have to integrate, or I have to find the total magnetic induction due to the whole wire. For that, so see, this is the angle phi. Actually, for my convenience, I am just considering it. This will be the midpoint. From the midpoint, the top side I can take, the angle will be phi 2, and the lower side it will be taken as the angle phi 1. Okay, so I have to integrate it with respect to the angle phi 1 to phi 2. Okay, in this case, so I can consider the lower point, that is the lower side, will be considered as a minus sign. Okay, in order to indicate that will be the positive and the lower will be the negative. Okay, if it is so, when I integrate this, that is mu naught by 4 pi into I by A will be the constant. If I integrate cos phi, I will get sin phi up to the limit minus phi 1 to phi 2. That is mu naught by 4 pi into I divided by A. Okay, sin of phi 1, sorry, phi 2 minus of minus plus sin phi 1. Okay. Right. Remember, this is an infinite long straight wire. For the infinite long straight wire, okay, so the angle phi 1 and phi 2 will be equal to 90 degree. So what will happen? Sin 90 degree will be equal to 1. So this will be equal to 1 plus 1 is equal to 2. So this term will become, okay, that term will become, that is B vector, or B will be, if I integrate dB, I will get B. So B will be equal to mu naught by 4 pi into I divided by A into 2. Okay, I can cancel this 2. Finally, I will get B will be equal to mu naught I divided by 2 pi A. What is this? This is a magnetic induction due to a long straight wire carrying current. Okay, it is very, very important question. And especially this one, you can notice one thing. So it is depend on the angle theta, sin theta. Okay, suppose if I want to measure the magnetic induction, okay, so for the wire carrying current, suppose if I have the current will be in this direction. Suppose if I want to measure the magnetic induction in this point, what would be the magnetic induction? It is going to be 0. Why? Because according to this point, the angle will be 0 in the formula. Okay, mu naught I by 4 pi into dl sin theta by r square. So here the sin theta will become 0. So the entire value will become 0. So when the current carrying current in its forward direction and also the backward direction, there won't be any magnetic induction. Only around the conductor we have the magnetic induction. If you like this video, like, share and subscribe. Thank you.